Welcome to the course module of Communication Engineering. And in this video, we are going to solve another GATE problem, which was asked in GATE 2020 exam. So in my previous lecture, in my previous video, I have already discussed about the uh, one of the GATE problem, which was related to instantaneous frequency of phase modulated signal. And we applied the concept of instantaneous frequency that we have already seen in my lecture classes. So again, a similar kind of problem is also asked in this particular exam. So let's try to solve this problem by applying the same concept that we have applied in the previous problem. Okay, so those who are watching this video first time, they must go through the lecture that I have already explained, okay, so that you will be able to follow this discussion clearly. So here is the statement of the problem that SPMT and SFMT as defined below are the phase modulated and the frequency modulated waveforms respectively, corresponding to the message signal MT shown in the figure. So here is the message signal MT given in the figure. And here are the expressions for the phase modulated signal and FM modulated signals are mentioned. Okay. So here is the expression cos 1000 pi t plus kp mt, and SFMT is mentioned as cos 1000 pi t plus kf integration over minus infinity to t m tau d tau, where this kp is the phase deviation constant in radians per volt, and this kf is the frequency deviation constant in radians per second per volt. Now, if the highest instantaneous frequencies of SPMT and SFMT are same, then we have to find out the value of the ratio of this two constants, right? Kp upon Kf in seconds. So this is our problem. Okay, so that we have to find out. So now I have already described you that in the lecture classes that the for any angle modulated signal, the instantaneous frequency is actually defined by this particular expression. So instantaneous frequency FIT is equals to 1 upon 2 pi d theta IT upon dt, where this theta IT denotes you the instantaneous angle of the given modulated signal. So for the case of phase modulated signal, this theta IT is nothing but 1000 pi t plus kp mt. So if we take this theta IT, then for the case of phase modulated signal, we can get this instantaneous frequency equals to 500 plus kp upon 2 pi into dmt upon dt. So just try to differentiate this particular expression with respect to time t and then divide it by the factor of 1 by 2 pi. Okay. So this will be able to, you will be able to get this particular expression, right? Similarly, if we take this theta IT equals to 1000 pi t plus kf integration over minus infinity to t m tau d tau, and if you differentiate it with respect to t, then you will be able to show that this expression will be equals to 500 plus kf upon 2m, kf upon 2 pi multiplied with the mt. So here you note that when you do the integration, if you do this differentiation of this particular expression, at this portion, you will find that this integration and differentiation will cancel each other, right? And therefore, we will be only left with this particular message signal m tau. Okay, so here you can note down this tau is nothing but the dummy variable, and therefore we can write this as the message signal mt itself, right? So this will be the expression of your instantaneous frequency of your FM modulated signal, right? So now here, if we wish to find out what is the highest instantaneous frequencies, right? So we have to find out the highest instantaneous frequency. Then for FM signal here, we can see that this will be directly depending on the highest magnitude of your message signal. So here, if you see this particular waveform, you will find that this empty signal is having this particular shape and its maximum value is equals to 10 volt. So here, if you substitute the empty equals to 10 volt directly into this particular expression, we will be able to get this highest value or maximum value of your instantaneous frequency in the case of FM. So please try to substitute this value. You will be able to get this result 500 plus kf upon 2 pi. And then this MT will be taking this value equals to 10 volt, right? Similarly, if you wish, because here we have to find out the highest instantaneous frequency for the phase modulated signal, then obviously we have to get the maximum value of this particular derivative, dmt upon dt. So we have to find out what will be the maximum value of this particular dmt upon dt. So let's try to see what will be the maximum value of this particular derivative. So we'll try to first find out what will be the derivative of this particular expression, this particular waveform, right? So let's try to do that. So to get that, we can see, first of all, what we can do is we can define the message signal empty in different time instants, right? So because here you can see this particular signal empty, which is being defined here, it is having a different shape in different time interval, right? So if we define the mathematical expression for this particular ramp, then you will find that this empty can be represented by this particular mathematical expression. Okay, in between this time duration, t equals to 1 millisecond to 3 milliseconds, right? So it is easy to show that this expression mt will be minus 5 plus 5t. Similarly, in interval 3 to 6 second, you will be able to show that this particular expression will be, because it is a constant, it will be 10, right? So mt will be equals to 10 in this particular time interval 3 to 6 second. Similarly, in the time interval 6 to 7 seconds, you will find that this is the decreasing ramp function, okay, with certain negative slope, right? So this expression for mt, you can write that it will be 70 minus 10t in between t equals to 6 seconds to second, right? 6 seconds to 7 second, right? So in this particular interval, this will be the expression. So basically what we are interested in to find out this derivative, okay? So you remember that writing these expressions are actually not required, okay? If you wish, you can write these expressions. Otherwise, you can directly calculate the dmt upon dt directly from the graph itself. Okay, so how to calculate that this derivative? So here you can see that because it is a rising ramp function, right? With the slope of, here you can calculate within the 2 seconds, this slope, this particular signal voltage is changing from 0 to 10. Okay, 0 to 10 volts. So therefore, this must be having the slope of 5 unit. Okay, so therefore, if you differentiate any ramp function, you are going to get a constant value, right? So that constant will have its magnitude equals to 5. So that we can do directly. And for any constant section, you will be getting a derivative equals to 0. And for a decreasing ramp function, again, you are going to get the constant value, and that constant value will be equals to having a certain negative value. Okay, why it is negative? Because it is having a negative slope, right? So that you can directly differentiate, or otherwise you can write this expression and you can go on differentiating these expressions, right? So if you do this differentiation, okay, of this particular expressions, okay, or you can do it directly if you have a good practice, in that case, you will find that the differentiation of this waveform will be having this type of waveform, okay? So in this section, it will be a constant value, and this constant value will be equals to 5. And in this section, okay, this particular mt is equals to constant, and therefore this its derivative is going to be 0, right? And in this section, the derivative will be having a certain negative value, and that value is equals to minus 10. So this kind of waveform we are going to observe in this particular time duration 1 to 7 second. Okay. So now, because we have to calculate the maximum value or highest instantaneous frequency of your phase modulated signal, and therefore we have to consider the maximum value of this particular derivative. So the maximum value here you can see in the graph itself, it is 5. Okay. So now we can substitute 5 over here so that you will be able to write this expression, instantaneous frequency maximum value will be 500 plus kb upon 2 pi multiplied with 5. Okay. So now in the problem, it is mentioned that this highest instantaneous frequencies of uh, phase modulated signal and frequency modulated signals are same. Okay. So what we have to substitute is we have to substitute that this Fi PM maximum equals to Fi FM maximum. Okay. So here is the expression for your Fi PM maximum. Okay, this is the expression. And in the previous page, we have calculated this value is equals to Kf upon 2 pi into 10. Okay, so that expression you can just make the substitution here, okay, in this particular expression. Then you will be able to show that this particular ratio Kp upon Kf, and this ratio is coming out as Kp upon Kf equals to 2 seconds. So this way we can crack this problem. Okay, so if you have any doubt, okay, then you please drop me a comment. Okay, I will be explaining it further if it is required. Otherwise, hopefully those who have watched my the lecture, okay, lecture related to this angle modulation, okay, and instantaneous frequency, they must be able to solve this problem very easily. So thank you for watching this video. If you have any query, let me know with your comments. Thank you.